right, seems like we are live. Welcome everyone to Flyte Community Sync. This is the December edition, and yeah, we're really grateful to have you all here. If you're just joining, just drop a comment in the chat wherever you're joining. If it's LinkedIn or YouTube, let us know where you're joining us from. And yeah, it's a very interesting session. And for those who are new here, what is Flyte and what is this meeting? Real quick, Flyte is a Linux Foundation graduate project, open source project, and I don't know how to define it these days, but it's a baseline to build a platform for multiple use cases, but all of it trying to abstract away the complexity of the infrastructure, complexity to build AI applications. I know that all of them are overloaded terms, but Flyte is doing it really well for thousands of organizations right now, and we have this rare privilege of having open source users volunteering to share their journey here live with all of you, which is great. Okay. Right. Before going to the presentation, well, welcome, Nelson. I don't know if you want to briefly introduce yourself.
Sure. Hello, everybody. My name is Nelson Araújo, and I joined as the head of engineer of Union. I'm super excited to be part of the Flyte community and all the workflows and use cases that enables.
That is awesome. Welcome. Yeah, this week, a couple of things. This is a big week. We're working on cutting a Flyte and Flyte Kit release soon. It's going to be big, mainly for two reasons. First, the number of contributors. The number of contributions has been significantly big this past couple of months, which is amazing in all fronts of the project: documentation, code, even core libraries. And that is amazing. And also, many of the changes and fixes that you will find in this release actually come from community feedback. So keep the feedback coming. Keep that. If you're wondering if you should report that issue, please go ahead and report that bug, report or that feature request, that idea you have. Please file the issue because that is help. Probably we don't have the bandwidth to prioritize everything, but eventually some of these things will actually go live. And also Union AI is at reInvent, and yeah, we were kind of announcing three main features that are now available at the Union AI platform that is powered by Flyte, by the way. One of it is cost observability. I know that you can get cost metrics from your cloud provider or your Datadog integration or any other integration. But this is very interesting because or the way I see it is kind of very fine-grained chargeback uh, to the to the extent of you can measure how much a particular execution cost to your organization, which is not usually available out of the box, and that is available for Union users or Union customers. And also, probably if you know Flyte a little bit, you know that every task execution by default is Kubernetes pod. So every time you trigger an execution, there's some latency that is not really Flyte imposed, and it is the startup time for the container and the pod. And once it's available to receive request, then the task execution starts. But what if you could reuse a pod for across multiple executions? What if you could have for a certain period of time a container just ready for you to trigger any execution? That will eliminate that latency attributed to the container orchestrator platform. So that is called Actors, and also it's also available at Union. And finally, serving this still unsolved problem out there, but Union is enabling serving with scale to zero and auto scaling. I can tell you how probably serving and auto scaling could be an oxymoron between them, but Union is making it possible with fast startup times, token streaming, real time serving, which is amazing. You can do kind of batch inference with Flyte and the Olama plugin, but this is real time serving. So for use cases that need it, this is great. All right, those were the public service announcements. So now let's head over to the presentation. So today we have with us Shuying Liang from the LinkedIn team. Welcome, Shuying. It's great to
Okay.
have you here.
Hi, everyone. Yeah, thanks for having me.
That's awesome. So yeah, would you mind introducing briefly yourself before going to your presentation?
Oh, sure. Yeah, I'm Shu Ying, and I'm currently working at LinkedIn, leading the next generation computer infra for stateless applications in the past 3 years. And recently, I have been leading this deep learning GNN infrastructure and platform. And so that's where I worked with the Flyte, and yeah, we're gonna share more today.
That is awesome. So let's add your preso here. I think you can go to slideshow now and we can hit over from there.
Just click the slideshow.
There you go.
Okay, all right. Yeah, just did the intro. I'm showing again, and I'll be sharing the insights into the Flyte Kubernetes, this data service agent, which is based on the Flyte agent framework, and we're going to show how it enables the distributed and scalable data services for the deep learning, especially in the GNN use case. So here we are gonna cover today, and first we're gonna do an introduction and the use cases and show why this is important and then how it applies to the general use cases. And then we're gonna focus on the GNN use case, of course. And then we're gonna do a deep dive into the design, the architectures, and the key components, right? And then zoom in and out of the system to show the scalability and the benefits on the Flyte and agent framework. And last but not least, we share some key lessons during our design and implementation. And also we're going to show how effectively that we leverage the Flyte agent framework to productionalize the custom agents. Okay, so yeah, so this is the deep learning, and in the deep learning flows, it always involves the data loading, the transformation, or the caching of the training data sets, right? And this process is often offloaded or executed on demand or while running simultaneously along with the training or inference in a pipeline fashion, right? And the infrastructure to support how and where to run this Kubernetes data services for the deep learning, right? To make it scalable and reliable along with the training or inference processes is the primary problem we're trying to solve here, right? This kind of infrastructure applies to the L inference, LLM training, GNN inference, GN training, or the online learnings, right? And so we're going to focus on the GNN use case today, right? So what is the GNN to start with? Right, the GNN short for the graph neural network is a deep learning model that designed to learn lower dimensional embeddings from the graph structure. And so at LinkedIn, the data structures are inherently a graph. And so we use this GNN bomb model trainings and to infer the nodes, the unseen properties of nodes, or the new relationship between the nodes via the edges, right? And then we do this node classification or link predictions, and then apply to the entire views, and then applies to the jobs, the recruiters, and that we're going to show the use cases later, right? And Yeah, so this is about the GNN and how to, what is the use case of LinkedIn. And here I provide a high-level view of how it works at LinkedIn. And so the input is a heterogeneous graph with nodes and edges, and also with the associated features. Right, this graph is and data set is generated and prepared by the LinkedIn AI vertical teams. It's stored to the Hadoop file system. And when the training starts, the graph data service, which we highlight as the graph engine here, will load this graph and the data sets into the memory. And then the mini batches will be created and be served to the GN training loop. And the output is embeddings that, as we mentioned, there's a lower dimensional embeddings and at this point, this embeddings like captures the signals from the business domain knowledge, right, across the vertical teams. And so it further fed into the downstream application model trainings, right? And if this high-level view is not clear enough, we have provided some mid-level view of how it works internally. And so you can think the GN training involves 3 stages. The first one is the sampling, the second one is gathering, and the last one is training, right? And it's impractical to train the whole data set or the whole graph. It's humongous, right? And so the GN training is usually do the sample-based training, where this we will have a subset of the topology of the graph will be sampled. And so, for example, here we have the source nodes like a 4, and then based on the graph data service, we can walk into the graph and get the 2 hops of the nodes, right? And we get samples the subset of the graph. And then the features will be collected and aggregated for the sample nodes, right? This is the second stage of the data service data processing part. And then the mini batches will be created, and the batches will be transferred to the GPUs, and then for the further the GNN training. So as you can see, the sampling and the gathering and the data loading part is the data service we're talking about here. And for the multi-nodes, multi-GPUs trainings, we already have the Kubeflows APIs like the MPI job, PyTorch job, or TF job to support this trainings of optimized for the framework, right? But for the data loading part, the sampling, the gathering, right? So to provision this kind of data services, like what is the construct to flexibly to provision that, right? And without diving into too many details and without losing track of the bigger picture, right? Here is the overall architecture that we're trying to achieve with the distributed, multi-nodes graph training. Right, the bottom half, the bottom part of the graph is the one that once after the batch is created, right, the forward passing and the backward passing across the GPUs and the nodes are kind of pretty well solve the problem, right? And then the zoom in part is the upper part where I zoom in here is involve the beyond training, right? The sampling, the loading, and the gathering, right? To support this distributed multi-nodes for the graph of features, right? How gonna to make that happen, right? And then so in our design, there are also some other factors we have considered. And so for the existing, we have the existing infrastructure and the data service for the graph for gen training, right? It's already integrated with the Kubernetes native primitives, right? And so, and we continue to use the stateful set to manage the data service pods. The other reasons that we're going to continue to use that is that the stateful set provides this native scheduling constructs where if your data service, data processing, right, program against the GPUs, and then this kind of constructs can enable you schedule your data service workload to the GPU nodes, right? And also you can choose to co-locate with your training processes or not. And so this is all very native primitives that are supported in the stateful set in the Kubernetes already. And so the other things that we use the stateful set for managing the data service pods is that it simplifies the operations, right? It has the built-in mechanism for for orchestration, for health checks, for scaling and recovering. So we don't need to do extra kind of things to make them more reliable or stable like this. Right. And so the other factors to be important is that the stateful set provides a very not static, but a stable, predictable kind of endpoints, network endpoints, where the training processes can reliably using that to communicate to the data services for health checking, for the data fetching. And as we alluded before, that the data services can load this graph data sets into the memory, or also can load into a preload into the NVMe supported SSD external storage, right? And so for stable settings can also support this this durability, right? Maintaining the data persistence across the past restarts. And so for all these reasons, you may have a few questions for later, but these are the reasons that we're gonna continue to use the stateful set to manage the data service. The other category of the important factors that we've considered is that we use of Flyte, right? The Flyte is the orchestration platform, and back in August or so that we have shared that LinkedIn has been migrating the whole training pipelines to Flyte orchestration platform. So GNN is no exception of that. And the good news is that the Flyte also already integrated with the Kubeflow APIs to managing this training or inference jobs, right? But for the dataset management, beyond training, beyond inference, right? How to provision a data set, how to scale these data sets. That is something that we want to enable in Flyte to streamline whole processes. So based on the Flyte, this whole the architecture, right? We have explored two approaches to enable this distributed multi-nodes, this deep learning training for GNN. And the first approach is based on the Flyte backend plugin approach. And so it has two variances of that. One is with the Kubernetes operator, the other one without Kubernetes operator, right? And so at LinkedIn, we also heavily adopted the Kubernetes operator pattern. That's where I mentioned before that we use the Kubernetes operator to provision or manage the stateless applications or stateful workload, right? And for the deep learning workloads, GNN's data services like this, it's a natural choice for us to do that. However, it turns out it's complicated and complex. So here are the things that we're going to need to do is like we had to define a custom resource definition for audience that are not familiar with the Kubernetes operator. So this custom resource definition is a sort of APIs for you to define the spec, the declarative for users to use. Right, and after defining your APIs, you have to implement your business logic in the controllers, which is in Golang. That we use the Golang because it's a better integration with the all the Kubernetes tool chains and have better optimizations for performance, right? But and then the next thing is that with the custom operators implemented, right, and you have to implement the Flyte backend plugins to CRUD. This custom resource definition so that you can make the operator to do its job, right? And then the interface for the Flyte and the operator is the custom resource definition. And so after that, you have to create the protos and then have the Python bindings, and then you have to define your task with DSLs in Flykit, right? And then along the product development process, or you have to test it, and you have to end-to-end integrity test it, and because of the changes involves the different places, all over the places in the Flyte ecosystem, it's not easy to integrate neither. And the last few steps, the processes involve the rollout. Yes, first you have to roll out your custom operator, right? And if you don't have your custom operator, you implement that logic to orchestrate, to manage your stateful set, your data services in the backend plugins. You have to roll out the backend Flyte backend plugin, which is in the Flyte backend again. And the other thing is that you roll out your SDK, which is in the Flyte kit. Right, and then you have to roll out the configurations. So this configuration involves the configurations for your custom operator. If you have the operator, it involves your Flyte backend plugins that you have to managing your new Kubernetes resources. Right, so also involve the roll out the configurations for agent services. Right, and so as you can see, this is like a very I think this is very mid-level kind of overview of the changes you have to make to enable this data services and orchestrate that with the training jobs. And the other thing I want to call out is that the teams that developing the custom agents is not the teams that may not be the team that managing the Flyte control plane or data plane. And so in this part, even you have like a development done, right, supported, you have to coordinate a lot of teams and especially central teams, like maybe among the orgs to make sure there's no regression, and also to support the new features. So with this kind of POCs evaluations internally that we have been through, and then we switched to the Flyte agent framework, right? And then this is have been significantly reducing our this complexity and complications in the development and the productionization and the maintenance, right? So in this approach, that you no longer need to implement a bunch of stuff that we've mentioned before. The only thing you need to do is to define your task with DSL and implement your logic in the agent. Is cleanly decoupled your kind of business logic from the Flyte ecosystem. You don't need to change it changes all over the places. It's also to test and integrate because the development, the main business logic is in your control. Right? You can test it and integrate test with the existing control plane or data planes in your staging or in your production, right? And so the rollout process is also significantly simplified because we have our own CI/CD pipelines where we do not need to depend on the central Flyte control plane or data plane. This rollout components roll out again, right? And you only need to roll out your agent, right, in your namespace, in your service account, in your service endpoint. Right, and the configuration is also simplified as well because you only need to roll out the configurations for your agent, right? And so, in summary, this leveraging this agent framework, to developing this custom agents, which in our case to serve the data services and orchestrate with the training jobs, it's simple, which is beauty, right? And then it's decoupled the architecture and with your you manage your own CI/CD pipelines. And so here provides a zoom out version, right? Stitching everything together. How does it look like, right? For the multi-nodes distributed graph GNN training and infrastructure. So there are three layers. So one is the first layer is the user space, right? The user space will define this data service task, where we're going to show you what does that look like in details in the next slide. Right, and here's some green boxes. Mostly it's our new components. Here is have some data service session where we use internally for LinkedIn users to seamlessly migrate to this platform. Right, and here we're going to show later also in details that what is used for. It's basically to provide a unique release name that you can use for interact between this data service and training jobs. Right, and also in the user space, right, the training or inference task that the Kubeflow supported, you can specify as usual. Right, there's nothing changed that needs to be changed there. Right, and so the second layer is when this data service is created and the Flyte ecosystem, the control plane will dispatch this this request to the custom agents to process that, right? Then the second layers is the business logic in the Flyte agent will be invoked, right? And basically we talk to the community we talk to the third layer, which is computer infra. It involves the scheduling, the Kubernetes API server control plane and data plane, right? And the Kubernetes APIs, the servers, after receive the request from our agent, right, it will create the stateful set, which is managing this data service paths, right, and expose the endpoints for data service endpoints for data service to be reachable within the Kubernetes cluster. Right, specifically, it's about to be accessible by the training pods that's managed by the MPI job. There's nothing changed there per se. Right, so here that is a more detailed views of what's the end-to-end user experience look like. It's very simple APIs that we provided. Again, the users in the user space will have you can provide a shim layer, right, to provide some of the any unique names, right? So for here, for example, that is a DS1234, right? And so in the data service task, the DSL, that user to specify how do I run my data service, right? Data processing, this logic, or the image, right? The image, of course, is, and here we use the deep GNN, which is as we mentioned before, is the graph data services supporting this graph operations and feature aggregations, right? And so here you provide is the remaining things is a pretty common spec for to running your data service. Is nothing specific to the GNN use cases or LM or like that. It's basically the your names, your resource requirements, number of replicas, how many kind of nodes you want to run your data services, right? And then what's the command to run your data service. Right, and the other thing is as we mentioned, that there's no big change. There are almost no changes to how you run your training jobs. We use a hoverboard job here, which is the LinkedIn version of the MPI job, which supports the custom commands and the things. For regular users, you can use the MPI job, specify your launchers and worker as you used to do. The only difference is here you specify environment variable, where you you specify, hey, what is the data service endpoints? I will have my training script to talk to the data service, right? And the data service here, endpoints, the DS1234 is example, is basically, as we mentioned before, the reason that the data stateful set provides a predictable and stable endpoints that we can use or reference among in this training or inference jobs. And so we also provide some simple APIs for users to specify, hey, I want to reuse the data service this path, right? I don't need to reload it again, and it can be reused across the workflows. Or reused by multiple different runs of your training or inference jobs, right? Or if you want to tear it down, you can say, oh, I want to clean it up, and so that's also you can specify that flexibly on demand as well. And again, so when after this data services task is created, this, as we mentioned before, the agent framework, the Flyte control plane will dispatch the request, right? Dispatch the task request to the custom agent, right, based on the task type, right? And in the data service agent implementation, which you implement your business logic in this callbacks supported in the frameworks, right? There's a create, a get, or delete. This async agent callbacks, right? In this callbacks functions, you invoke the API servers to create a stateful set, right, and create a service endpoints with the release name, right, DS1234-0, which is port 0, and with the port 4000, which is example here. And then in the training, the backend, plug in the MPI job, which is integrated with the Kubeflow in the Flyte already, right? It will create this MPI job to managing your training pods, right? The training pods running your training script, and there's knows like what the endpoints to talk to your communicate to your data service, and also for the health checking or for the to fetching the data. Right. So you have developed and you have the developed this the GN training platforms, right? And they want to productionalize it. And the productionalize it is also the agent Flyte agent framework also enable that reliably as well. And one of the things we want to highlight here is some common mistake that I've seen in the implementation, because as you notice in the Flyte kit, there are a bunch of custom agents or tasks, right? And then for your testing, for you to start with, you can use the existing setup, right, to provision, to develop your own custom agents. We just give some examples in the gray boxes here. And you can use that, also use the existing setup to roll it out, for testing, right? But that cannot be rolled out in production because many things can go wrong, right? So basically, if you're using that, using the Docker files in the Flyte kit, to roll out your custom agents, right, and use the deployment, in the production, there's a single point failure. One is that the service endpoint, when that goes wrong, all your custom agents will go down. This is downtime for the training in across all verticals or teams, right? And so there are other things can go wrong. Is that usually if anything goes wrong with the deployment Helm charts, for example, right? And then that can bring down the whatever agent's logic in that deployment. And also, even with those things going on fine, you have your pod, with the running on the nodes. If anything goes wrong with the nodes, right, your pod goes down again, and so this will impact all the custom agents as well. So in other words, in production, we have made a leverage in the Flyte framework, right, and also to completely decouple this custom agents from the central Flyte control plane, the data plane rollouts, and also from the other custom agents. So basically, we create our own namespace. You and recommend to use your own service endpoint. And for authenticate with Kubernetes, in our case, you have your own service account, right? And so this is the separation of concerns. You can also set up your own dashboard metrics and to monitor your custom agents. Right, here's just a high-level overview. What does the CI/CD pipeline for your custom agents look like? Some of them is specific to LinkedIn, but most of them applies to general custom agents, right? You so basically create your own kind of Docker files, right? And with the dependencies compiled into the image, right? And then you have your basically the deployment, your service account, which is in our case is authenticate for authentication, right? And if you roll out to different regions or data centers, so that is something up to your kind of organization or your use cases. So the other things is the agent for the custom agent to work with the Kubernetes. You have your agent role and bindings, and so here there's no leak of these permissions because you only specifying the roles and the bindings and the RBACs to managing the resources you need for your custom agents, right? It's also very easy to go through security review in the organization. And here is just showing some LinkedIn, central release tooling that you roll out your agent, per environment, per data center, right? And so here is showing that the configuration change, as we mentioned before, right? So we decoupled a lot of the configurations rollout, right? But one of the things remaining piece that still depends on the centralized Flyte rollout is the agent's configuration. In that one, you specify agent endpoints and your what kind of a task type you support it in your custom agent. So that currently is still in the Propeller centralized centralized Propeller configuration. So for that, we have created RFC to the OSS Flyte, right? And how we can illustrate how we can decentralize the custom agents configuration and rollout, right? And so with that, it's 100%, decouple everything, right? To ensure your custom agents, you can can run and monitor the operation productionized reliably. Here we summarize some of best practices with Kevin. We have done some kind of a co-presentation to LinkedIn internally. So if you have the same, so for example, some of the top lessons that we want to highlight here is that please sync frequently from the upstream, because you don't want your engineers precious engineering time spending on debugging or workaround of the old bugs or some missing features unnecessarily, which is already solved in the upstreams, right? And also, again, I want to highlight again is that we just use this Flyte agent framework to to manage your CI/CD pipeline, not just the development, to ensure this reliability and the quality production quality of your custom agents, right? Yeah, so with all that, currently the AIP's AI platform, our data services that supported the AIP is rolled out to all the training clusters. And here we're showing that for the LinkedIn trainings, we have like two major primary data centers to do the trainings, and one is in Texas, the other one is in Virginia. And so in each of the data center, there are multiple Kubernetes cluster, and so the data service agent, right, that is rolled out per Kubernetes cluster. Right, we have new region to spin up as well, so we can easily to spin off this agent in the new cluster in the new data center, right? And the current use cases on this platform span across different business vertical teams that include jobs and ads, recruiters, members, and so and also the future plan that to leveraging about this solution is the extending the centralized agent, the data service agent, for our legacy TensorFlow data loaders, or essentially potentially some LLM data processing as well. With all that, I think this conclude all the major content in the our multi-node distributed training for the GNNs. And here I want to many thanks to our LinkedIn AIP platform, the bunch of folks, Ankit, Yitong, our manager, the Animesh, the director, with the support of this work, and our vertical teams, customers, right? And so importantly, I have Kevin's and Hanru, very generous support and help us to debug a lot of things to make this happen, and also have some very insightful discussion and insights from the Haytham and Captain for this decentralized custom agents discussion, right? And have David for organizing this forum for us to share the experiences with the other companies as well. And so for the data services, graph data services that we are leveraging the Microsoft Deep GNN solution, where Alice and Co have provide the kind of support as well. And so for NVIDIA, we have a bunch of some collaborations for scale this GNNs even further, right? With the NVIDIA folks, Joe Eaton, Rachel, and Tristan, and Advin, for organizing a lot of stuff. So yes, many thanks to all of you guys. And for that, I'm happy to take any questions for now. And yeah.
Yeah, that was amazing. Thank you, Shuyin. A lot of information there, a lot of work, tenacity to make this happen. Thank you. And yeah, there are a lot of people excited. Andrew is one of them. So he's the AKA feature outlier. Yeah, feel free to post questions on the chat. I don't see a question there yet. I have one. Where is it? I think you mentioned several best practices, which is interesting. By the way, is one of the most common questions in the Flyte community. best practices. And one of the goals of this space is exactly that: share the experience of others. I was curious, and probably I should know it, but for the benefit of the audience, why is it best good practice to not override the default sensor agent, but create your own?
I'm sorry, what's the question? In
Yeah,
the
yeah. There's one particular best practice. I think is the fourth one. Yeah, do not override the default
oh,
sensor agent, but create your own. I'm curious, what is the reasoning behind it?
oh, for that one is so in the Flyte kit, there a default sensor type of the task and some handling of that. And so in the, I think it's mostly in the older version. And so in that, we have like you implement your own sensor, and that this sensor can override this default sensors, and then and also have some mess up. Like the request will not know like which sensor implementation to route to. And I think should be already solved in the newest Flyte kit. But for any people using the older version, yeah, just implement a new sensor type and the implementation, so to avoid kind of issues like the messed up sensor task and the handling of that.
Got it. That's great. Makes sense. Yeah, I I was chatting with a Flyte user this week who had a similar question. Hey, how does routing work on agents? And it's kind of like that. I mean, you define a task type, and it will be routed to the specific agent that is, say,
Yeah,
registered to do that task type. Mhm.
yeah. So here, I think is some of the configurations here. This is the agent configuration that is propeller config map, where supported task type, you have sensor, this is a default, or whoever override that sensor. Then the data service sensor, we specifically is different type of that. So that the propeller does not route this request for the sensor to our data service sensor, or our data service sensor task does not route it to the default or overridden sensor. So this is some configuration based routing from some configurations that's to specify what exactly the sensor implementation that's for your sensor task. I think, yeah.
Yeah, that makes sense. Thank you. Thanks a lot. And yeah, thanks from the audience too. All right. Yeah, I don't know if there is any other question. I don't know if Nelson wants to comment something. I don't know. I don't see other questions in the chat.
Yeah, I really like to thank you for showing the work and share the practices with us and the audience, the community. Thank you.
Yeah, I think this Flyte, based on this agent framework, I think so I want to highlight is a significant reduce the complexity and complication, right? Like to develop and productionalize and maintain this deep learning platform. I appreciate that. And also, I'm also working with Kevin, and so we're going to open source this K8s data service
Mm.
as well. And because we are currently roll out a bunch of vertical teams to use the platform, and so once that is stabilized, and then we're going to contribute back to the OSS flights. And we also think there are a bunch of folks that reach out for the design choices. Why not backend plugin? Why not with the Kubernetes operator? Why directly using agent framework? So we share some in some previous slides. Basically, it's the simplicity, and simple solutions. Yeah, to improve the productivity and the velocity. Save a good ROI. Basically, I think.
Yeah, I'll take your phrase. Simple is beauty, and that's so true. Yeah,
Yeah.
that is amazing. Yeah, yeah. Actually, looking forward to that contribution. If folks out there in the community have questions around the Flyte agents framework, join the Slack community. Uh, all of us are there, usually available to try to answer your questions. We don't have all the answers right away many times, but we'll keep pushing to try to help you. And yeah, I think with that, thank you again, Shuying, for joining, for sharing so much useful information. And we hope to see this evolving and helping also LinkedIn users out there in the world.
For sure. Thank you for having me again.
Awesome. Have a good day.
Thank you.
See ya.